Alright, so once you get the 3 points on the circle, we drew the circle, put the 3 points, and then I'm just going to play connect the dots. We're going to make a triangle here. So each vertex of the triangle that we're drawing here is on the circle. Okay, now, what you actually have here, and we're going to get into this in a little bit more in the definition, this circle exactly touches each vertex of that figure. That circle is called circumscribed about. If you have a circle that goes through each vertex of a polygon, that is called a circumscribed circle. And I just want to show you the special property with this really quickly. So we're going to do a little construction that we've done before. I'm going to draw a perpendicular, it's going to be a perpendicular line through the point C, and it'll be perpendicular to one of the sides of the triangle. We're going to do this for 2 different sides in the triangle, and I'm going to show you how these lines interact with each other. So to draw a perpendicular line, I'm just going to use this horizontal line here in my triangle. You can pick any one of the sides. All you have to do, this is going to be like 3 steps. I'm going to put the little gold piece on that center of that circle. Now, I'm just going to make a little arc, and I just need it to touch on 2 sides of the side that I'm going to draw a perpendicular line. So use whatever number you want. I just used 31 on mine. All right, so I just had the center on the C, and I just made a little arc, and I just needed it to touch that side in the triangle in 2 spots. Where it intersects there, I'm just going to actually make a point. And I'm going to grab my highlighter. So these 2 points are equidistant to that center of that circle. What I want to do, I just highlighted this, I'm going to draw a perpendicular line to this little segment I just highlighted. And hopefully you guys will remember, we did this much earlier in the year, but it's a really quick construction. All you have to do for this, you're just going to put the little gold piece on one of the endpoints of that segment. So I'm on the side in the triangle, one of those endpoints we just drew. And all you have to do, pick any number you want, but it has to go at least halfway across the segment, and you want to remember whatever number you're using. So just at least halfway across. I'm just going to use 27 on mine. You can use whatever you want, but you want to kind of make like a little bit of a decent sized arc. Whatever number you just used, I just used 27. You got to just switch over to the other endpoint, and you're going to do that same construction. So just whatever hole you just used, I used 27, so whatever you just used. The reason you have to go at least halfway across the segment is if you don't, these 2 arcs we just drew won't intersect. To get the perpendicular line, all you got to do is connect the 2 places where those arcs intersect, and if you did this correctly, it should go through that C, that center of the circle there. So I'm just going to draw this real quick. And I just used my highlighter to do it. So this is perpendicular. The other thing you guys might notice, and I know we didn't necessarily talk about this at all, that line that I just drew actually bisects this side in the triangle also. If you look on either side of that, it might not be perfect, but that should be the midpoint of that side in the triangle. So it's actually the perpendicular, and it's called a bisector because it's going to split it into 2 equal pieces. Okay, now all I'm going to do, I'm just going to repeat that process real quick, but for one of the other sides in the triangle. So it doesn't matter which one. I'm just going to rotate my paper a little bit. I'm just going to do this side of my triangle. So pick one of the other sides in the triangle, and I'm going to repeat that process real quick. Or actually, tell you what, I'm going to do this side. It doesn't matter. You can do either one of the sides. I'm going to do this one. The first step, you're just going to put the little gold piece on that C, the center of that circle. Now, whatever side you picked to work on for your triangle, you just need to make a little arc, and it just needs to touch 2 places on that triangle. On that side, I used 40 as mine. And I'm just going to kind of emphasize where that little arc intersected that side in the triangle. shape this up a little bit. And I'll just highlight it a little bit so you guys can maybe see it better. Now, I'm going to draw a line perpendicular to that line. So I'm going to use those two endpoints that just created from that arc. And again, you just put the gold piece on one of the endpoints and just go at least halfway across the segment. I'm just going to use 27 again. Make it easier for me to remember. Once you make your arc, just flip to the other endpoint. Use the same number. I use 27. Use whatever you want. And if I connect where those two arcs intersect each other, that'll be perpendicular to that little segment I have highlighted there. And if you do this correctly, you should see this is going to go through the center of that circle. And the other thing you're going to see is it intersects the other perpendicular line that we did. So this is perpendicular here. I'm going to rotate this back so it looks straight on my paper, but hopefully you guys saw this. If we did that same construction on the third side, it's going to get a little bit jumbled up, but if we did that same construction on the third side, we would also run into that point that is in the center of the circle. This is actually, that point is called this, it's the center of the circle, but it's called the circumcenter for the triangle there. All right, now I'm just going to give you guys a couple definitions at the bottom. The circumcenter is the first one we're going to talk about. And we just drew perpendicular bisectors of two different sides in that triangle when we did that construction, so that's going to be related to the circumcenter. Just in general, point of concurrency, I'm going to write that there's 4 for any triangle here. We're going to get into 2 of them today. But point of concurrency is actually just the intersection of 3 or more lines. We just drew 2 of them, so our construction up there wasn't too jumbled. But if I had drawn all 3 perpendicular bisectors of the sides of the triangle, all 3 of those lines would have run into each other at a point. Okay, now, just to remind, I know you guys know what a perpendicular bisector is, but a perpendicular bisector is going to cut a segment into 2 congruent segments, and it's going to be done at a 90-degree angle. I'm just kind of abbreviating a little bit. So a perpendicular bisector is going to cut a segment into 2 congruent segments, and it's going to happen where it intersects the segment at a 90-degree angle. Now, I'm not going to construct this here. I'm just going to like eyeball it. So you guys will see this on the quiz. There will be a picture just like this, a blank triangle, and it'll say, sketch me a picture of a perpendicular bisector. All right, you can do that for any of the sides on your sketch. I'm just going to do it for this side that goes across the bottom here. So what I would be looking for, we're not a construction, we're just going to sketch. All right, so a bisector would cut that segment into 2 equal segments. So I'm just going to do my best to kind of eyeball the very middle. And I probably didn't do a good job doing that, but just kind of eyeball, just a sketch. And for me to indicate that I'm trying to say that's right in the middle, I'm just going to mark on either side that those 2 segments would be congruent. So I'd be looking for this on your quiz. This marked congruent, that's the bisect part. And then just to the best of your ability, this is a horizontal line that I'm going to be the perpendicular bisector for. So I'm just, to the best of my ability, just draw a vertical line. Best you can. It doesn't have to be perfect. We're not actually constructing this. We're just sketching a picture. But then also, for me to know that it's perpendicular, I would want you to put in a mark there to indicate that that was a right angle. So I'll just use that little box there. And that would be a sketch of a perpendicular bisector for just one of the sides. All right. So if you can do that, there's literally a question like that on the quiz. Just kind of recreate that drawing. Perpendicular bisector. Could you sketch me a picture of it? That's what I'd be looking for. Okay. Now, what's special about this? I'm going to just, a lot of this is just fill in the blank, and then I got some big diagrams for us to draw on. Okay, so in the first blank, I'm going to write symbol for perpendicular. So the perpendicular bisectors. And I'm going to just put a little 3 in parentheses because there would be 3 of them. We're going to talk about a triangle. So the perpendicular bisectors of the sides of a triangle are concurrent, which just means the 3 lines would run into each other at a point, and it's going to be, that next blank is equidistant. So same distance from the vertices of the triangle. And I'm going to give you just a bunch of pictures here so you can kind of see the illustration. Some of them have certain information, others don't, so I'm going to kind of walk you through it. So in this picture right underneath here, here's the diagram. You've got a triangle, ABC, right? Now I'm going to highlight the perpendicular bisectors because there's a bunch of different lines going on in this problem. So P to Y, P to Z, and P to X. Those are perpendicular bisectors. If you see, each one of those has got a right angle, and then like on either side of X, the 2 segments are marked congruent. On either side of Z, the 2 segments are congruent. On either side of Y, the 2 segments are congruent. So those are the perpendicular bisectors. We could draw those out farther. They just stopped them in the diagram where they intersect. The point P there is the circumcenter for that triangle. Now, the circumcenter is going to be, that property right above says it's equidistant from the vertices. To show that in the diagram, that's what the little dotted lines are. So from P to A, from P to B, and from P to C, those distances are each the same. And they wrote it on the paper, like right next to that, it says PA equals PB equals PC. So from that point to any one of the vertices of the triangle, those segments are all exactly the same length, the little dotted lines. And then I just want to show you underneath here, depending, this is an acute triangle in that diagram. Depending on the type of triangle you have, the circumcenter can be in different places, excuse me, in the diagram. All right, so I had an acute one, you just saw that on that question right there, but here's another example. So the circumcenter is the intersection of these perpendicular bisectors. So they have 3, each one drawn for each side perpendicular bisectors, and they just draw them as lines. They're all the way extended through. They don't stop at that circumcenter, but that's what I've highlighted there. In that case, for any acute triangle, that circumcenter, as you can see there, it's inside the triangle, in the interior of the triangle. Okay. And you're going to see this in the example at the bottom. We're going to put this on a graph, but you'll see this in the homework too. If you have a right triangle, which I have a right triangle here, where those perpendicular bisectors all intersect each other for each of the sides is actually on the triangle. It will be on the hypotenuse of the triangle specifically. So if you got a right triangle, the circumcenter is going to be right on the triangle. And then the last possible triangle you could have is what I got here to the side. If you've got an obtuse triangle, that just means one of the angles is obtuse. It's going to be this angle in the diagram right here. You can see here the circumcenter is actually outside of the triangle. We'll work with this a little bit more with our constructions, but it can be any one of 3 places depending on the type of triangle you have. So acute inside, right on, obtuse outside. Okay, now this is just an illustration of the circle that we did on the front to kind of connect this back. All right, so the circumcenter in each of these pictures, in this one it's P, and in this one it's the letter O, so they used a couple different letters, but that's the circumcenter. It says, since the circumcenter is equidistant from the vertices, you can use the circumcenter as the center of a circle that contains each vertex of the triangle. That's what we were doing on the front. And then this is described as, this circle is circumscribed about the triangle. So you can see here, this distance from the circumcenter to each vertex, they don't have the perpendicular bisectors marked in that diagram. Those are each the same. And the reason I know for sure they're each the same, this is just a radius of the circle, right? From the center to a point on the circle, that's a radius. From the center, A's on the circle, that's a radius. from the center. That's B is on the circle. So each one of those is just a radius of that circle. Now, this one does not mark those distances, but here you go. Here's your circle. Has the perpendicular bisectors. O is the center of that circle. If you wanted to sketch it in, like A to O, O to B, and O to C, each one of those distances would be exactly equal. It's just a radius of the circle from that center to the vertex. Really what you got to remember here, if you have the perpendicular bisectors of each side, it's going to intersect at a point, and that point's called the circumcenter, and it is going to be exactly the same distance to each vertex of your triangle. Okay, now we're going to actually draw it. So you guys are see questions like this in the homework. So I'm going to have us just draw a triangle here in example 1. So it's ABC gives you 3 points. A is over 2 up 7. B is over 10 up 7. And C is over 10 up 3. And I'm just going to go ahead and connect the sides here. Okay. Now, you guys, hopefully you can tell, the A, B, and BC, those two, one's a vertical line, one's a horizontal line, so those intersect, and this would be a right angle here. So it's going to ask you to find the circumcenter. Because that's a right triangle, I know the circumcenter should be actually on this triangle when I draw this. Okay, now, 2 of the sides, which is what I would recommend, are really easy to find the perpendicular bisector. We're just going to sketch some straight lines here. So if I look at the side from A to B, that's a horizontal line, right? So I just need to find the middle of that. So this goes from 2 over to 10. So right in the middle of that would be 6, right? Now, all I got to do to get a perpendicular line, if I've got a horizontal, I'm just going to draw straight up and down. Right? Because the horizontal line and the vertical line are perpendicular to each other. So that's just me drawing the perpendicular bisector. I don't need to construct it. I can just use the grid marks on the graph to help me with that. Now, it would not be something that would be easy to do for the side from A to C. I could show you how to do it. But we really only need 2 of these lines to find the circumcenter. Because all 3 of the perpendicular bisectors will intersect each other, but I only need 2 of them. So if I have a vertical line, I can do exactly the same thing I just did here. I'm just going to come right in the middle. This goes from 3 up to 7. So right in the middle would be at 5. All right, and then perpendicular to a vertical line is just going to be a horizontal line, so I just need to draw a straight line that way. And you guys can see where those 2 guys intersect. That's going to be your circumcenter. And that point, it looks like, is 6, 5. Now, it's a nice one on here. The 2 problems that you're going to have where you do this on the homework, you're going to have a 0.5, but it's just going to be like, like 3.5 or 2.5 or something like that, so it's not a bad number. But don't think you're doing anything wrong if you get 0.5 as a coordinate when you're doing this. Now, before we do the other one, it's called the incenter. We're going to finish this real quick. I'm going to show you how to draw the circle. Okay, so this point, your circumcenter, is the center of a circle that goes through exactly each vertex of this triangle. So if I want to draw the circle, if I have the triangle there, here's all you have to do. Put the little gold piece on that circumcenter. So that point we just found, 6, 5. Now, you could do this with any one of the vertices, like C, B, or A, any one. Just find a hole that goes right through any one of the vertices. And it should be the same hole if you've got it lined up right. I'm pretty sure it's 28. Scooch this to the side a little bit here. And then I'm just going to hold my finger on either side of the gold thing so I can rotate this. I put my pen in at 28. And I'm just going to go all the way around to make this circle here. And once you draw that, you should see the circle goes through each vertex here. Exactly. So it's a circumscribed circle. The triangles on the inside, the circles on the outside. That is your circumcenter. It's equidistant from each of the vertices of that triangle. Is anybody having a question? Okay, the other one we're going to talk about today, we're not going to do any constructions with this at all today. We'll do one later. This is going to be called the incenter. And the incenter you're going to find by using the angle bisectors for each angle in the triangle. So angle bisector, all that is, it's going to be, it's usually a ray. It could be a line, it could be a segment, but I'm going to write a ray that cuts an angle into two congruent angles. So going right down the middle of an angle. And remember, I told you guys on the quiz, I'm going to give you like a blank triangle and say, sketch me a picture of an angle bisector. So that's what we're going to do here. You can pick any one of the angles. I'm just going to use the one up at the top here. So I'm not constructing this. This is just an eyeball drawing. So I'm just trying to do my best. I'm going to draw a little ray the best I can right through the middle of that. And what I'd want to see if you guys were doing this on a quiz, just to let me know that you're sketching an angle bisector, just on either side of that ray, just mark those angles as being congruent to each other. And that's all I'd want to see. Angle bisector just goes right through the middle of an angle, cuts into two equal angles. And if you draw all three of those, one for each angle in a triangle, they're going to intersect in a point, and that's going to be called the incenter. So that's the other one we're going to talk about really quickly right here. All right, so the bisectors is this first blank of the angles of a triangle are concurrent. Concurrent just means they run into each other at a point, and this is going to be the word equidistant again, which is an equal distance. Now, the circumcenter is equidistant from the vertices. The incenter, and I just started to write vertices again, fail. All right, it's equidistant from the sides. So this is just a little different. It's going to be equidistant from the sides of the triangle. And in the diagram right below here, I'm just going to show you real quick. So they stop the angle bisectors at the incenter where they intersect each other. So I'm just going to highlight them real quick. So P to B, P to A, and you can see these segments are different lengths, so these are not the same length. All right, and P to C, those are each an angle bisector for that triangle ABC. They run into each other. The point P in this diagram is what we call the incenter, formed by the angle bisectors all being drawn and run into each other. Okay, now, what they're marking with the other little dotted lines is the special property here. So that point, the incenter, is equidistant to the sides. So the little dotted lines here, P to Y, P to X, P to Z, and it tells you right over here that those are all equal to each other. It's equidistant to the sides. And we talked about this a little bit in our last lesson. If I go from a point to a line, to measure that distance, you have to do it at a 90-degree angle, so that's why you see the little right angles there. And hopefully you can kind of see from eyeballing the diagram, each one of those little dotted lines, those segments are the same length. Now, what the deal is with that, yeah.
So what's the difference between an incenter and a circumcenter?
So circumcenter is going to be equidistant to the vertices. So the vertices would be like A, B, C. So like P is far away from that. Like these are all different lengths. This one, if you look down here, is going to be a circle. Circumcenter is the circle outside. Incenter is going to be a circle on the inside of the triangle. So that's the main difference. Well, they're formed by different segments, but this one's going to be an inside circle. And the other thing that's different from the circumcenter can be in three different places, inside, outside, or on. The incenter has to be inside the triangle. If you find that with the angle bisectors, it's going to be the center of a circle that is exactly contained. It just touches each side of this triangle, but it's completely inside. That circle is called an inscribed circle because it's inside the triangle. That's how I remember it. The incenter is inside, so it's an inside circle. The circumcenter was the outside circle. Circumscribed is going to go around the outside. So this one just really is trying to illustrate the circle. This one here actually puts the angle bisectors in the picture for you to see it. So those are your angle bisectors. And obviously those are all different lengths. If this was a circumcenter, those lengths would be the same. What's the same here is each one of the distances from that in-center to the side is exactly the same. And that's just a radius in that circle. So in this x to I, y to I, and z to y, or z to I, each one of those segments is the same. It's just a little radius of that circle. Actual problem you guys are going to see is something like this. So immediately in the diagram, I see these three segments, B to G, A to G, C to G. Those are the angle bisectors. If those are the angle bisectors, the place they intersect, which is G, is going to be the in-center for the triangle. So if I see a distance drawn from that point G to one of the sides, like for example G to F or G to E or G to D, each one of those segments, and you can probably eyeball this from the diagram, but each one of these segments are going to be equal to each other. Now what they tell you in the question, let me just write this down real quick. So G to E, G to F, and G to D. Each one of those segments would be the same length there. In the directions, they tell you GE and GF, and those two are equal to each other. So I'm just going to set those two expressions equal real quick. So 2x minus 7 and x plus 4. Each of those represents a segment from the in-center to the side in the triangle. I'm just going to solve this real quick. I'm going to subtract x. So from 2x, that'll just give me 1x minus 7 equals 4. I'm going to add the 7 real quick. That'll give me x is 11. The question says, what's the length of GD? Oops, I'm not on the screen, sorry. Which, that wasn't even involved, but if you plug 11 back in, 11 plus 4, G to F, that would be 15. If you did it to the other one, 11 times 2 is 22, minus 7, also 15. So this would be 15. All three of these segments I got highlighted on mine are the same length. So G to D would also be 15. Got to find the variable first and then plug it back in. Main things to remember today. So circumcenter is formed by the perpendicular bisectors of all the sides of the triangle, and it's equidistant from each vertice, outside circle that you can form there. In-center is the angle bisectors, and it's equidistant to the sides of the triangle, and it's the center of an inside circle. So I always remember in-center is the inside circle, and that's called inscribed. The circumcenter around the outside is called circumscribed. So a lot of vocabulary today. Is anybody having a